Traditionally, the construction sector, when you look at from the welding point of view, we are considering a lot of pre-engineered buildings and the technology that is getting more and more modular, which means aluminum foam formwork, a lot of pre-engineered structures which are prefabricated in the shop, taken on the site and quickly erected. Typically, arc welding, MIG welding is what is used for these applications by and large. We will discuss how we can adapt to the newer technologies and migrate to the next process and how will it help in terms of productivity. So here's a small chart which shows you comparison between deposit rates for arc welding, which is right at the bottom, about 400 grams to 5.5 kgs per hour. And then you have MIG-MAG, which is at 600 grams to max of about 12 kgs. Then you have flux core, which is about 1 kg per hour to a range of about 15. And single wire submerged arc, which starts from 3 kgs per hour and can go up to 16 kgs per hour. Of course, there are variants in submerged arc which can take it further higher. But for the sake of our discussion, this will be good enough. Most commonly used process is arc welding or SMAW. You would have seen this image almost at all sites. This is called arc welding, where an equipment is used along with an electrode to strike an arc. This process is man dependent. It usually cannot be automated. So it's a if the processor is welder dependent, you need to remove the slag after each run of welding, chipping. There's a lot of spatters which are involved, which means grinding post welding as well. Of course, at the end of each consumable, that is a length of 300 millimeters or maximum 1 meter in cases of shipyards, you need to change the consumable into the next. There's a changeover time and a stub end loss. That is the end part which the welder would not be able to fuse simply because it will be too hot. So that's something called a stub end loss which occurs. And how do you now migrate from this or increase productivity in a process such as this? First, we can upgrade to inverter-based power sources from traditional transformer and thyristor power sources. This will help reduce spatters, make cleaner slag, also help you save on energy. That means your energy cost goes down drastically. When we move from arc welding to MIG or flux core welding, you can see the kind of productivity increase we can get. These are electrode types. So if you look at 7018 welded in uphill position, you will get a deposit of about 0.65, that is 650 grams per hour. If you look at 6010 cellulosic electrode and downhill, 1 kg per hour. Then you look at low hydrogen deposit 1.18. And the minute you start moving into flux core arc welding, you get 1.62. Move into semi-automatic flux core arc welding, NG, that gives you about 1.78. If you mechanize it, that means put this onto a trolley. We will see all that later. You can get a deposit of about 2.43 kgs. And if you completely automate GMAW, that is used gas metal arc welding, deposits can be as high as 4.41. And with dual torch or dual wire, we can reach up to 7.5 kgs per hour. So moving right from 0.65 to 7.5 is possible. Now, if you look at the advantages of moving from arc to flux core or GMAW, arc is a manual process, low investment cost, metal recovery is low. That means per kg of electrodes that you buy, your deposit rate is lesser. Stub end losses are high, no gas is required, which is a plus point. High speed in root passes is possible because you get higher mass deposited per square millimeter. When you look at flux core arc welding, it can be manual or it can be mechanized. Investment is higher compared to submerged arc welding in terms of the capital cost of the power source. So a typical 400 ampere arc welding power source will cost you about 40,000. A typical flux core arc welding power source would cost you about 80,000. So initial investment is higher, but the metal recovery is even higher. So per kg that you spend, you recover more. Metal is deposited onto the job. No stub end losses. They come in 15 kg spools, and it can be self-shielded or gas shielded. It's mainly used for fill-up and capping runs, not for root runs. Now, when you mechanize the system, this is the old way of welding. You can see two people using electrodes to weld the pipe. Kind of joint chemistry there to keep, geography there to keep was this. The included angle is larger, you have a smaller root face, and more metal is required to deposit. However, if you mechanize it, that is, put it onto a trolley or an orbital track, you can reduce the gap, thereby putting lesser amount of material on it and having higher productivity. So this is what can be easily achieved. Training of welder, you need to do if you want to move from arc to MIG, the same welder needs to be retrained. Basic MIG welding power source will be required. If you're doing FCAW or GMAW, you may need gas such as argon, CO2, or mixture of argon and CO2. Semi-automatic, that means you can use tractor, trolleys, things like that. It can be easily automated. You can use single or twin torch per process. What's the return on investment? If you move from arc to MIG, you can have 2.5 times faster process, so more productivity. One welder in place of 2 or 2.5, more metal per kg deposited, more metal per hour deposited, and you can easily mechanize the system. For the forging industry, this was one of the case studies done. For every quantity of 100 kgs deposit, efficiency of submerged arc is only 60%, whereas metal coat wires was 94%. That means you use, if you were to deposit 60 kgs, if you bought, you would have 100 kgs. If you bought, you would only put in 60 kgs. Whereas in metal coat, if you bought in 100 kgs, you would put in 94 kgs onto the job. So if you look at the saving on preheating costs is almost 80%, 80% saving on timing and 80% saving on costs. So it makes a lot of sense to move into the newer processes as soon as possible. Industries, these are possible too: structural welding, prefab, pre-engineered fabrication, pipe to flange welding, forging repairs, and hard-facing applications. Let me quickly take you to another process from which we can migrate from arc welding to thin wire submerged arc. Thin wire submerged arc makes a process is possible for using from between 5 to 15 millimeter thick plates. Uses smaller power sources like 600 amps. Welds with solid wires of 1.2, 1.6, and 2 mm. Speeds are more than 7.5 times of arc welding. Already it's a standard usage in the PV industry up to 10 to 12 mm thickness, and also for pressure vessels to fill up and gases. So here's an example where a 5 or a 6 mm thick vessel is being fabricated using thin wire SAW. This is a 1.2 mm wire, and the productivity is going up 7.5 times. Not to mention, when you use the submerged arc process, the weld quality also improves, deposit also improves. Here is another way of welding the pre-engineered structures. These are the H-beams, I-beams that are being fabricated. Small video just to show you how we can migrate. And this is how the system can be very easily mechanized and easily used at a lower cost. Of course, the saving of time is very high. Productivity is 7.5 times higher than the normal one. Here's another example of just using simple tools to enhance the productivity. This is typically how you weld the beam. You would have to weld both these faces. So you would do one fillet this way, either turn the job around or turn the trolley around and do the welding on this side as well. This takes a lot of time and also a lot of effort on the welder's behalf. However, if we change only the nozzle to the 45-degree nozzle, if you can see here, and this way you could weld both the sides from the same trolley only by flipping the torch around 180 degrees. So you are welding this, turn it 180 degrees, and you start welding on this side. So the space saving is there, time saving is there, and no extra help required. Productivity improves. So in summary, from arc welding, we can move to flux core, which is a constant voltage process to improve the productivity 2.5 times, or to thin wire submerged arc, which can help you increase the productivity to almost 7.5 times. Quickly diving into GMAW processes, I hope I'm on time. Maybe give me about a minute more. If you look at GMAW processes, is another widely accepted process. It can be extensively used in heavy fabrication and automotive sector at the moment. Very high speed process. You can easily be automated, higher metal recovery, no stubborn losses. You can use cell shielded or gas shielded wires, and narrow gap preparation is possible. How does this help? I'll just show you quickly. These are the more advanced new power sources that come. They come with pre-structured programs, which helps take away the skill from the welder. You only have to choose the material, the gas you are using, the wire thickness, and the material thickness that you want to weld. It automatically derives the parameters for you, gives you basic programs such as jet arc for high penetration, modulated arc for softer and faster arc, and root arc for better control on short circuit. If you look at this productivity improvement from normal GMAW to mechanized, this is the normal GMAW, bigger V, and when you move to mechanized, you can see single pass per layer, and therefore much lesser material required to weld. At the same time, better strength of the geometry. These are the high-end power sources called Pro Series, which are modular in nature. Each one of them is only 200 amps. You can keep adding to build up your capacity. If anything goes wrong, imagine it to be like a RAM in your PC or a hard disk. Just change the LAN card cable to the next one, and you can use it at a lower capacity. Remove one, repair, replace, and start again. Because they are modular, the airflow is left to right, not for front to back. You have very quick cooling, and therefore you can have 100% duty cycle. That means more arcing time and less stoppage. These are highly efficient power sources up to 96%, therefore very low power consumption. They come in IP34, so it's very easy to use on construction sites. Can save up to 100 programs in the memory that can be recalled very comfortably. Digital in nature, very simple tools which help operators quickly change the parameters without going to the power source itself. So they are double tapping the torch to change the program. If you look at the screen, and you can always recall the first, go back, go front, only using the torch itself. So this saves the operator to go back to the power source and change the power. Very easy. You can also have RFID protections where you have your program stored in RFID. When you swipe it, the welder can only access the parameters given to them, and it locks the rest of the parameters. Obviously, IoT is the name of the thing which is in at the moment. You can capture all the data, throw it over a weld web, and the secured data transfer can happen over cloud or on your local server, and you can monitor real-time welding and analysis of the operator's performance. These are advanced power sources. They come with very high control of waveform, which allows you to have much better pool control, which means you can weld root passes directly, having lesser amount of time required to weld the overall process. So here is a welder welding with the Pro Series root gap directly with the solid wire MIG process. This saves a lot of time and allows the welder a lot more control on the weld pool and gives you much higher productivity. So many more programs are there in these which help you achieve this. With this, I would like to stop the session because we'll move into TIG. But for construction industry, I think ARC, MIG, Submerged Arc are the processes which help them speed up their productivity and are most used. So with this, I would like to conclude my presentation.